Now we'll take a look at the effect of the power pin setup on our test results. We're going to move a couple of pins into their own power pin groups so that we can control them separately. As you can see, I'm creating two additional groups. Our original group 2 is for the VCC power pin. The next group, group 3, is for the output enable. And the last group, group 4, contains the direction pin. We'll see in a moment how this affects our plot. We start with all three of these pins set to 0 volts. Let's execute the test. Note that this time we are curve tracing only 16 pins. We select all to display all the pins, and we see that this plot looks the same as before. We have this curve at about 700 millivolts, and the diode on these pins are all enabled. Now let's see what will happen if I change the VCC from 0 volts to 5 volts. We start the test. Notice that I didn't change any other parameters, just the VCC voltage. And it should be finishing. What happened? The plot looks completely different. Does this mean the plot is not real? No, it is as real as the other plot. Simply by putting 5 volts on the power pin, we trace the curve of the pins while the device is powered. Notice that DIR and the output enable no longer go to the same voltage. They stop at 0 volts. Why? Because we move the reference point for the upper diode to 5 volts. We never reach a point where this diode is enabled. Also notice that some other pins also stop at 0 volts, while other pins go to the limit. The A pins go to the limit. I can just hide all of the A pins, and you can see that the B pins do not go above 0 volts. If we invert the selection and show only A pins, we see that they all go to the limit. Let's look at the device drawing to see what's going on. Since we have the output enable set to 0 and it's active low, we have enabled the output buffers. At the same time, the direction pin will define which direction data on the pins will go. Going back to the CurveMaster, let's change the voltage on the direction pin to 3 volts. That should be enough to affect the device. Let's run the curve trace again and see what happens. The plot has changed again. We invert the display, and we can see the effect of the direction pin. Now let's set the output enable to logic high, say 4 volts. Can you guess what will happen? Let's start the test and run a new plot to find out. This time, all of the pins have stopped at 0, except the 2 pins that we've applied voltage to. Why? Well, the output enable now disables all of the output buffers, preventing them from syncing or sourcing any current to the CurveMaster. You may or may not fully understand the mechanics of this, but the important thing is to know that the plot you get from your device depends on the conditions you set for the test. For example, if I set VCC and the other pins to 0 volts, the plot will change. We return to our initial plot where all of the diodes are enabled. This demonstrates the flexibility of the power pin setup feature of the CurveMaster. When you hardwire your power pins to ground or to a power supply set to 0 volts, you will always get a result like we see here. With the ability to use the power pin setup feature, we can disable the upper diodes and see if perhaps the input buffer is damaged in some way. And these pins DIR and output enable are not power pins, they are control pins. But by using the power pin setup, we can change the internal state of the device under test. This feature is not found on any other standalone curve tracer. It is a powerful tool unique to the CurveMaster. This concludes this training video.